Good morning. It's time for another experiment here. As we finish our Unit 2 in science, we're going to look at how do we use technology. Friday, we did a lesson on technology, and today we're looking at how do we use technology. And it's going to be a fun little digital lesson, and we're going to be looking at how to make a really cool paper airplane that flies a certain distance. So I think you'll enjoy this lesson. Let's go ahead and get started.
Welcome to the lesson, How Do We Use Technology? In this lesson, you're going to investigate a technological problem and how it can be solved. You'll use a model and evaluate solutions for the design of a model airplane to meet certain requirements. Was the paper airplane successful? In this lesson, you will use criteria or standards that will help you decide. When problems or needs are identified, we use our knowledge, tools, and processes to find solutions. The methods we use and the solutions we find are called technology. We use technology in many different ways. Click each image to learn more. A game console involves technology that we use for entertainment. A basketball shoe is a type of technology that helps people play a sport. A telescope is a technology we use to see distant objects. A roller coaster uses technology to provide a thrilling but safe ride. Airplane technology enables us to travel great distances quickly. Information technology includes systems and devices that enhance communication. Technology is used in various ways to make our daily lives easier.
How do you use technology? Have you used any of those before? Microwaves are nice, aren't they? They're a type of technology. Cooks things much faster.
Information technology includes systems and devices.
You use your computer. You use your computer for school. That's nice. You get a lot of information. You use an airplane. Anybody ever ridden in an airplane? Yeah, we can get far away places pretty quickly. Roller coasters are sure fun. Can see things far away with a telescope. I bet a lot of you have some basketball shoes, and I'm sure a bunch of you have used game consoles. So technology is very useful. We use it every day.
Since the Wright brothers' first flight in 1903, aircraft technology has made global travel possible for millions of people around the world. What kinds of problems do you think had to be overcome to develop aircraft technology? How do you think people went about solving these problems? Watch the video of airplanes in flight and think about these questions. Click the play button to start the video.
Wow, that was amazing, wasn't it? What kind of things do you think they had to solve? Problems do you have to solve in air flight when you're flying an airplane? Well, you got to make it fly first. I don't want to get anything that goes up but doesn't stay up. I want to make sure it's going to fly. Did you see those planes? They were able to go loop-de-loop, go upside down and turn back around. And then as they came down, they let out a trail of smoke somehow. They just design in the sky. Lots of questions of technology with airplanes. Let's see what else we have learned today.
In this activity, you're going to investigate the design of a model airplane to meet certain conditions. The plane's mass must be less than 6 grams. The plane must be able to fly at least 4 meters, and it must be possible to adjust the plane's surfaces to make it rise or descend. Here's what you'll use. A model airplane. You will launch the model airplane and observe its flight path. An electronic balance. You will use the electronic balance to measure the airplane's mass. Controls to adjust the airplane's tail flaps. You will use controls to change the tail flaps. A distance measuring tool. You will measure the distance the airplane flies. A data table. You will record data in this table.
All right, so we've got lots of tools, lots of things we're going to do today. Let's go try it.
In the course of exploring the model airplane design, you'll be able to make some changes and see the effects. For example, you'll be able to adjust the airplane's surface by raising or lowering its tail flaps. How do you think raising or lowering the airplane's tail flaps will affect the plane's flight? Type your prediction in the box, then click OK.
What do you think? So a plane's flying along. If it's got things on top of it, if we raise the tail flaps up, what's it going to do? To me, it feels like the wind's going to catch that. It's going to want to pull it up. So I'm thinking if we put tail flaps up, it's going to make it want to go up. And tail flaps down, it seems like it would catch it and make it want to go down. That's my prediction. Would you have the same prediction? We'll try it. We'll type it in. If the flaps are up, it will fly upwards. If the flaps are down, it will fly downwards. I don't know if that's right or not, but that's my prediction. It's what we're going to test and see. That's what scientists do, right?
Continue to see if your prediction is correct. In this activity, you'll be able to measure the airplane's mass, the distance it flies, and how adjusting its tail flaps affects its flight. How will you investigate whether the model airplane meets the desired conditions? Type your plan in the box, then click OK.
Okay, well, first we're going to need to check different masses. So how heavy or how light the airplane is going to affect it. Secondly, we're going to need to put the tail flaps up. We'll try with the flaps up and down. Okay. What else are we going to have to do? You think it depends on how much force we throw it with? I don't know if we get to do that or not. It would make a difference. Sometimes if you throw it real hard, it just goes straight down. I don't know. Let's see what happens.
Check your plan. Did you set a goal that include these steps? Measure and record the plane's mass.
Yeah.
Launch the airplane and record the distance it travels for 3 trials.
We're going to do that.
Raise the plane's tail flaps.
Yeah.
Launch the airplane and record the distance it travels for 3 trials. Lower the plane's tail flaps. Launch the airplane and record the distance it travels for 3 trials. If your plan does not include these steps, you can change it. Once you've finished, click the next button to move on.
Well, I guess the only part we didn't put in our plan, we should have probably put that we're going to try it 3 trials because there were 3 boxes there to fill in. So we can go back and add it. We'll put try these things 3 times.
There are different ways to carry out an investigation like this. The first condition you need to check is that the plane has a mass of 6 grams or less. Click this button to test condition 1. Drag the airplane to the electronic balance. Record the mass in grams in the table.
Okay, so what is the grams? Looks like it weighs, or its mass is 5.9 grams. We always want to put our labels on, so we put a G there for grams. Okay.
The second condition you need to check is that the plane can fly at least 4 meters. Click this button to test condition 2. You can carry out this test with the tail flaps level. Click the run button to launch the plane.
Okay. So here we go. Looks like it flew pretty good to me.
Click the measuring tool to open it. Use the measuring tool to measure the horizontal distance that the plane traveled.
From him, it goes all the way over here. 4.56 meters.
Set the tail flaps to both up.
Okay. Try again. I think it did make it go higher, don't you? I guess we'll measure it again. I'm not really sure what we're supposed to do here right now. I'm figuring this out with you. I guess we're supposed to top it in up here. So with the level, the trial one, it went 4.56 meters.
Observe that both the airplane's tail flaps are up.
Mm-hmm.
Record distance data for 3 trials and find the average. When you're done, repeat the steps for the tail flaps set to both down.
Okay, now we know. Let's put them both level again because we need to fly it 2 more times with level. Okay, so a little bit farther that time. Like 4.75 meters. Okay, we're set. But one more time level. That wasn't a very good one, was it? That flew the least distance. 4.31 meters. Okay.
Record the distance in the table.
Let's put both up now. And let's try this flight again. I think we were right when we thought it would go up with the flaps up, don't you? Aren't you? Don't you? Okay, so flaps up. Now we're to 6.17 meters. Try again.
When you've entered your data from the 3 trials, click the calculator to open it.
Okay, we'll do that in a minute. What happened that time? It kind of went down, didn't it? Huh. We had both up. Okay, 6.22 meters. And last time with both up. Whoa, he's going way up this time. But he came down fast. Maybe just a tiny bit farther. We'll say 6.29. I think that was the best one. Okay, let's go back up here and find the average.
Click the reset button to clear the trial. Repeat the trial 2 more times.
Okay, I think we didn't do it in the right order here, but we're okay. So do you know how to find an average? What you do is add the numbers together, and then you divide them by how many numbers there are. So how many are there right here? 1, 2, 3. So let's add them together. 4.56 plus 4.75 plus 4.31 equals, and we're going to divide it by 3, and our average is 4.53 with a bunch of 9s, so we'll make it 4.54. Now later on in math, we will learn we don't say 4.54, we say 4 and 54 hundredths. But you don't know that yet, so we'll learn it later. Let's find our average for these 3. So we're going to hit the clear button. 6.17 plus 6.22 plus 6.29 equals, we're going to divide by these 3 numbers again, and that gives us an average of 6.2. We're going to round it up to 6.23 meters. All righty. Now we've got one more experiment to try. We're going to put both down. Okay. And here we go. Let's see what happens. I think it's going to go down faster. I think I was right. Okay, let's measure that old flight right there. He's way back here at 3.91 meters. Try it again. Yeah, this isn't working too good, is it? Well, it's not that far. Maybe just a little bit farther. 3.96 meters. One last time. Oh, it went just a little bit farther. All right, 4.29 meters. All right, now we need to use our calculator and find that average. We're going to add these three together. 3.91 plus 3.96 plus 4.29 equals, and we'll divide by 3 since there's three numbers, and our average is 4.05, as we'll round it to that. Why won't you let me type? 4.05 meters. What can you tell from this chart? Which one flies the best? It flies the best with both of the flaps up, doesn't it? You get the farthest. Okay.
You wanted to investigate the design of a model airplane to meet certain conditions. Its mass had to be no more than 6 grams, it had to fly at least 4 meters, and it had to be possible to make the plane lift or descend by adjusting its surfaces. Were these conditions met? Can you explain how adjusting the tail flaps affected the plane's flight? Type your conclusions in the box, then click OK.
Okay, so if it had to fly at least 4 meters, which way would not work? We couldn't have both flaps down because 2 of the 3 times it didn't make it to 4 meters, did it? So even though the average was 4.05, this one was a lot farther than these two. I wouldn't trust a plane with its tail flaps down to go 4 meters every time. But consistently, with both up or level, it went 4 meters, excuse me, each time, both of those times. So were the conditions met? The conditions are met with the tail flaps level or both up, but not with both down. Can you explain how adjusting the tail flaps affected the plane's flight? Okay. With both up, the plane flew, it went higher, didn't it? And it went farther.
The airplane's mass and the average distance it flew without adjustments to its surfaces were within the allowed values. Therefore, the first 2 conditions were met. When the plane's tail flaps were